All right, so energy profiles, that's what we're doing now in this video. Now you have an x and y axis. So the x axis is always the progress of reaction, and that means that you're starting off with reactants always, and that's how you end up with products. Okay, your reactants, the reactants, they react, and then you end up with products. Okay, it's never the other way around. Okay, so it's never the other way around. It's always you start with reactants, they react, and you end up with products. And that is the reason why the left side, you always have the reactants on the left side. Okay, and now your y-axis is the energy level. Okay, so it doesn't matter where your reactant is. What matters is what you get marked for is where you put the energy level for the products in, like, relative to the reactants. Okay, so it doesn't matter where the reactants is. So I'm just going to place that here as well. Like, honestly, it doesn't matter. Now you need to think about products. So in exothermic, what happens is that the reaction gives out energy to the surroundings. So the reaction itself becomes the temperature, the energy inside the reaction itself decreases. That's why the products here will have less energy than the reactant. Okay, because the energy was given out to the surroundings, so the products have ended up with less energy, right? So after you draw the reactants and products, make sure you draw that curve. Okay, and you need to label it a bit. So let me use this. Right, so the peak of the curve, so from the reactants to the peak of the curve, that is the activation energy. So this at the top is the activation energy. Okay, and then from the reactants to products, that is the energy change, and you have to label it whether it's negative or positive. So exothermic is negative, and I will tell you that in a bit. Why is it negative? Do not write minus, you can write negative energy change. All right, so yeah, that's it. But I'm making this video, I want you to understand what is happening in the diagram, because if you understand it, you can deal with any kind of question. So let's see what is happening. Now your reactants, they will not result in successful collisions here, because they haven't reached the minimum activation energy to initiate a reaction. Okay, that's why they do not react over here. So you increase the energy of the system. Okay, you keep increasing until they reach that activation energy level. So at this point, what happens is that reactants are breaking bonds. Okay, so breaking bonds is an endothermic process. So here, endothermic reaction is taking place, and that has a positive energy change. Okay, and then so when your reactants are all broken down, and then depending on the conditions, they then form new bonds. And when they form new bonds, you get new products. I mean, like, obviously products are always new, but you get products. Okay, so forming new bonds, that process is an exothermic process, and that has a negative energy change. And this is the reason why the overall energy change, you see this bit, so you see this bit, that bit is in excess. Okay, that bit, because this is the positive energy change, and this is the negative energy change, and you can see that the negative energy change is more than the positive energy change. That's why the overall energy change here is negative. Okay, right, so if exothermic is fine, now let me draw endothermic. So we have our reactants here. Then endothermic, the reaction takes in energy from the surroundings, so the energy inside inside the reaction will increase, so the products will have more energy. Okay, and again you draw that curve from the reactant to the products, and again from reactant to the top of the curve, that is this is the activation energy here. That bit here is the activation energy. Okay, same for that one. Okay, right, and then that excess, so that distance between the reactants and products, that bit is the energy change. Okay, and here it will be positive, and let me explain why. So remember, breaking bonds is an endothermic process, so that side is having a positive energy change, and then making bonds is an exothermic process. So that bit is a negative energy change. And if you look, you have more negative, more positive. You got more positive and less negative. Okay, so the overall energy change is positive, and that's why endothermic reactions, they have a positive enthalpy change, and exothermic have a negative enthalpy change. I hope you understood why. So for the purpose of the exam, you only need to show this much. You need to show the position of the product relative to the reactant. So you need to draw both of them. You need that curve. You need to show where the activation energy is. So which bit is it? And you also need to show the enthalpy change. This is the overall enthalpy change. Okay. Same for that one, but I won't be able to erase those yellow and red bits. But basically the black and turquoise bits, that's what you need to draw in the exam. Okay. And I've usually I used to see past papers last year. They are usually 3 mark questions, right? So yeah, now only bond energy calculations left, and I'll do that in the next video.